So in the last video, I said that the RAM has volatile memory, and volatile memory is where all the software and variables and things are saved, stored for a section. But as soon as you switch it off, it goes with it, right? It vanishes. So all of these numbers vanish. If I switch off in the middle of a Firefox or a Safari, something, an internet browser, whatever web page I was on will now disappear, right? It has no recollection. And the only reason why it does have recollection, you might turn your computer back on, and it might say pick up where you left off, open up the pieces of software where you left off. Just as you press that switch off button, even if the power goes out, there's things in the operating system that will really quickly save really important bits of information of whatever you're running, and it will store it quickly on the hard drive effectively. So when it says would you like to restore, it's getting the pieces of information. It might have stored it on a hard drive quickly, and there might be a section on your hard drive that's file named something along the lines of disaster recovery or switch off recovery or something. And once your software closes down, it'll quickly save some of your settings, like what web page you're on, for example, and then it'll let you open it back up. So we can have these sort of these seamlessly long software openings where you can close your computer down, open it back up again, and then the software loads back up. Well, actually, no, that's actually on these. That's on the hard drive. It's not on the volatile RAM. So what is this volatile RAM? Well, I mentioned it briefly to do with in the caching section, not in the caching section, on the motherboard. Sorry, because the CMOS is volatile memory, if you remember. Now, effectively, what's going on is you can imagine three-dimensional space, right? This is a three-dimensional space thing here. So we have up and we have down, we have left and we have right, and we have forwards and we have backwards. Just this is the world we live in, right? This is called the x-axis, the y-axis, and the z-axis usually. Now, in this 3D space, imagine me having a pen. So I've got a dodgy picture of let's say of a fountain pen there, and there's the tip. Now this pen, I'm going to assume that this is the orientation of it. It's like this, right? So the nib of the pen, the tip of the pen, is up in our world, in our space. So if I twisted the pen, I could also put it this way, right? I could put it along the x-axis. I could put it down, and all I'm doing is literally take a pen in your hand and flick it around and turn it around in a circle. Effectively, that's all I'm doing, right? And I'll get into why I'm using a pen in a second. But if I get this pen, I can also, now if I draw it like this. Now this is our, this is our box. This is our Z dimension. This is our depth. I can draw the pen. I can put the pen like this. I can put the pen like this. Like that. And I can also put the pen that way, as in going in the opposite direction, pointing out. So there's a three-dimensional space of where I can put the pen. I can also put it coming out of the page, as it were, coming out at me. So I literally have every single point. I can point to everything. If I hold a pen in my hand and use my arm, I can point to basically everything in any single direction in 3 dimensions, right? If I say point over to that corner of the room, and then the top right corner of the room, and then that corner of the room behind here. So this corner of the room, this corner of the room, the corner of the room that's also here and here and here, everywhere basically. Now imagine if I get this pen and I shrink it down to the electron size. Let's go back. We're talking volatile memory here, right? What does this volatile mean? Volatile. Sorry, I won't even try it. So we're talking volatile memory here, and what now happens is when you've got this RAM stick, this, and we'll have a look at what they look like in a second. We've got, let's say we have states here. We have little things here. And within these things, we have atoms, let's just say. It's made of something. Those somethings are made of atoms. And inside those atoms, there are electrons. Remember, so you've got the atom here, and then you've got your electrons here. So sorry, the nucleus here and the atoms. The nucleus here and the electrons here. I keep calling them atoms. This whole thing is an atom, right? So, and now what I can do is take this one electron, and this one electron has this thing called spin. It's similar to magnetic north and south pole. So north or south. Sorry, I don't know why I wrote an 8 there. It's my hand just doing whatever it wants to do again. North and south pole. So it's the same thing. Now on a spin, the difference is I can have a north and I can have a south, but I can also have an in, just like this pen in three-dimensional space. I can have a Z direction, so like pointing outwards. I can have pointing inwards. It's not just north and south and east and west. I also have in and out, right? And because I got this in, out, left, down, up, right business, I can actually get this pen to start wobbling in every different direction in space. I can point to every different direction in space. That means that the electron spin is working in a very similar way to this. So this electron can spin either up or down or left and right. I'll get a picture of this actually, because it's kind of a hard thing to explain. But it can spin in every single direction. Well, actually, if I put electrical current through, if I put some electricity, I can manipulate the spin and I can keep it in a sort of state of north or south. And I like to think of it as north or south. Now, if we do have this dichotomy of north and south, I have a 1 and a 0. If I can create physics out and have a 1 and a 0 and this duo sort of symbol, then I can usually think of a way to manipulate it to represent binary code, right? It's relatively simple. So what's happening is it might be spinning a little bit up there. So you might get it pointing here, and you might get it pointing sort of here, but you might get it pointing roughly here, and it's spinning around, but it's generally in a direction. It's generally in this north direction, and it's also similar for this south direction, right? So I can also get it to come around here-ish. So it's pretty much south. It's pretty much pointing down all the time. Now, the fact that I've got this pointing down means that it's south, and the fact that I've got this pointing up meaning I can say it's north, but I need to make sure it's always... by the way, this distance is very small. This distance is not very big at all. We're already talking about electrons, so it can't be very big, right? So this difference in space, we can say, in fact, let's just have a neater model of this, and redraw it down here, and just say, okay, I now have a north and a south facing spin of an electron. Now this north and south facing spin of an electron is actually what's stored inside of RAM effectively. So this is what is happening inside RAM at the physics level. There's a lot more going on, don't get me wrong, and if you wanted to learn more about this, then great, but it takes a lot of physics to be able to truly appreciate what's going on here. So I'm taking some of the information out, but effectively I've got a north and a south pole facing electron spin, and that is incredible because I can now store data that way. I can spin this electron north, and I can spin this electron north, and I can spin this electron south, and I can spin this one in a north and this one in a north. Well, actually, if you read this, I read this as 1 0 1 1 0 1 1, etc. So now I can store information in electron spins, and it sounds a really fancy thing, and it is in many senses. It's quite a complicated thing that's going on. But the point here is once I start and this is where the volatile comes in. This is like the main point. Once I stop the electric current going through, once I switch off the electricity, so if I don't plug it in and I switch off the electricity, then this state, instead of having a nice neat state that's staying up here, no, the state of the electron just wants to wobble all over the place. It wants to wobble in any way, which way and forwards. It wants to wobble left, right, forwards, backwards, up, down, and everything in between. So it's just it ends up actually just being a lovely state that's north and south. And then as I switch the electricity off, as I cut the power, it's actually going, it's north, it's south, it's no, and then blah, blah, it just scribbles. And it's now literally physically every direction, and we don't really know what direction it is because it's just spinning in every single direction it possibly can. Now I have no idea what the hell this means. I don't know whether that's a 1 or a 0 or a what. I have no idea. There's no data there. The data's gone. This is not data anymore. This is data. This is data. This definitely not data. So this is what we mean by volatile memory effectively, is that that the physics of it requires a constant electricity going through it. And we'll talk more about this in forensics and in the further hacking, but I hope you appreciate now that volatile memory is a sort of state of physics.